responsibility factor. So can everyone hear me okay? Am I good to go? All right, good. I think everything's been working out pretty good, being in my basement in the dungeon here. It's kind of cold down here, so I get my little jacket. It's like in the 50s down here, but it's a little brisk. I like it, actually. All right, so changing books. I love that book. It's about this thick, super thin, and we're going to use that book the whole semester, never going to deviate from it, except for maybe a worksheet here and there, but the worksheets come from the book's ideas. I love this book. My favorite book of all time. Very clear, concise. You could actually read examples, and it's very user-friendly. So, yeah, use it when you can. If something's insufficient, what I've done in class, I hardly ever deviate for what they do. Really like their approach, too, on things. I think they do approach things in the most simplest manner. Not all math books do that. The green book, a little tougher read. If I told you to read the book and then, it's rough. This one's great. All right, I'm going to jump right into it. This is mostly geometry review, but we have what I said last hour, like the backbone of what you need to know for the rest of this year. I mean, there's many things, but this is like, if we don't get the last concept down like immediately, or you don't get it over the weeks, you're going to really struggle on a lot of things. All about different approaches to angle measures. Actually, this is it right here. I call this concept 1, like I did in the Ed puzzle. I tried to break it down into concepts. But really, this is concept number 4. But we're going to start with this giving you an idea. And then in concept number 4, we're really going to break this down. But, oh gosh, do we have to write that? I don't know. We're doing geometry, so we better know the basics of geometry. What a line looks like, what a segment looks like, and what a ray, like a ray gun, has a starting point and then goes through infinitely another point. I think we know that. That's like grade school stuff. This is not. This is the backbone of what I'm talking about as far as knowing something new. But you may have done this in math too. I'm not really sure. It really depends how far you went into trig. Don't think you guys go very far anymore. It does make me sad. Coffee break. All right. Now, what this implies is, I'm going to take a long time. So really, the notes, someone said they didn't get all the notes last hour. I really think I'm taking my time here. So let me try to keep up. This is when we get to concept number 4, the idea of putting an angle in a coordinate plane. That's what I did. I superimposed a coordinate plane on this angle measure. Okay, and then you'll find out more about this later, what angle in standard position is. And it's an angle that starts at the positive x-axis and then rotates in one direction or the other. What you're going to have to know is when an angle rotates in a counterclockwise direction, then the angle measure is a positive angle. And you just got to get this down, man, and lock it in. This is the backbone of what we're going to be doing the rest of the year, knowing when I go counterclockwise, it's a positive measure. When I go clockwise, it's a negative angle measure. And that's it. You either memorize it or you don't. I'm being crass. This is why probably some people don't like me. I don't care. I don't care. Some things you just got to lock in. There is no reasons for it. There is no I don't get it. All right, so let's give an angle measure that is reasonable for what this directional angle is here. What would be a reasonable answer for what this measure is? Well, I know I went 90, then another 90, then another 90. So it's greater than 270. So I'm going to make up something and say it's 300 degrees. Reasonable, possible guess of what that angle measure would be. But the big deal is it's positive 300. That tells the person that you went in a counterclockwise direction. By the way, I mentioned this before. Counterclockwise, maybe it was in the Ed puzzle. I don't know if it was live with you or in the Ed puzzle. Counterclockwise seems to be the norm. Or maybe it was my other class, because we're kind of doing some geometry right now. Because when we name the quadrants, we go 1, then 2, then 3, then 4. The norm, going in order mathematically, seems to be counterclockwise in a lot of things, just like in naming the quadrants. You should know that 300 degrees in the future ends up in quadrant 4. because it's greater than 270. All right, we'll say instead of going this long convoluted this direction, let's say you went directly this direction. And then this is our concept later, the term called coterminal angles. Coterminal angles are angles that end at the same terminal side. So instead of going in this direction, I went directly this direction. That would be 60, but it'd be negative. What you're telling the person is that you went clockwise instead of counterclockwise. Hey, what's the relationship between, put it in the chat, but in the chat, here's a new rule. I like this because then it comes in like a machine gun, like the answers. Let me go 3, 2, 1, answer, and then put it in the chat. What's the relationship between 300 and 60? What do you think the relationship is there? How come I knew that was negative 60 if they landed in that position? 3, 2, 1, answer. Let me see if I get them to put it in the chat. How did I know it was negative 60 to land in that same position? Ooh, Michael was so excited he answered twice. Nice. Or what's 300 plus 60? Put that in the chat just to see if you're alive. Alex, nothing? I see you looking around. Isabella? 360. What Michael said. Aiden, thanks, Mike. Michael, 360 would have been shorter than writing the sentence what Michael said. Just saying. All right, yeah, they add up to 360, and that's really the main idea today, like one of our big things. Okay, but then we have a lot of reviews. So concept number 1, a little leaking into concept number 4. Please, I really hope you don't have to write this down. Concept number 2, look at that acute angle because it's smaller than 90 degrees. Right angle, come on. Obtuse, give me a break. Straight angle, yeah, straight angle adds up to 180 degrees. These are just things we need to know. So up here, not that you necessarily have to write this down. I think I mentioned this. Yeah, I did mention this Wednesday. We use Greek letters a lot of times to label angle measures that are in degrees. Theta is the most popular one. So just make a note to self on that. All right. I don't know if you're writing this down. I really don't think we should be having to do that. I hope we know these terms like the back of our hand mathematically. But I will zoom this out, and then your world is about to get bigger. It's about to get way bigger. Angle is probably up to this point in geometry, and I'm not really sure how much geometry we even teach anymore. But angles are going to get bigger than 180. They're actually going to get bigger than 360. They're going to get nuts, right? We actually have an angle measure today of 1,000 degrees. And whoa! I just want you to think of this. I do this every year. I used to teach at Providence. I don't even know where the Providence building is in New Lenox. Anyone? Good, thank you. You know that Kmart was there? My window would actually face the Kmart. I always yell at the students, stop staring at the big K, pay attention in class. All right? I'd see them staring out the window during my notes on the chalkboard. But then also I use Kmart as an example when I would teach this. If you were in Kmart's parking lot, Kmart actually closed, sadly. And you did, in this winter, a donut. What does a donut imply? What do you actually do in your car? And actually, a donut implies you did a 360. So everyone understands what a 360 is. You end where you started. So facing the big K, I do a 360. I end up facing the big K again. What if you do 2 rotations, 2 donuts? Then you understand that that is not a 360. You're having more fun. That is a 360 plus a 360, which is a 720. This is where your world... Aiden, are you okay? You're holding your head like it's about to explode. Okay, all right. Hey, and by the way, this is funny. Look at how I see you guys. You're on a big TV. I had to get a big screen TV to have the chat in here, so you guys are like really big in my screen right now. So that's why I saw you yawning, Aiden, and holding your head like it's going to explode, my over-explanation. All right, but anyway, I hope you understand how we can go greater than 360. It's all about rotational moves. Then if I do a negative 360, I just went in a different direction to end up where I started. So getting those seeds planted in your mind as we move forward. This is kind of a connection to the backbone of what we need to know what's going on. Okay, and then a couple other simple terms in this concept number 2, which is just basic geometry review. When I say angles are complementary, they add up to 90. When I say they're supplementary, they add up to 180. The reason I have the C and the 90 highlighted, order. C comes before S. 90 comes before 180. A lot of times students flip-flop these and say complementary angles add up to 180. I want you to stop and think and use that little device I just gave you for not screwing up those two. So what's concept number 2? A bunch of geometry review. Acute, right, obtuse, straight, complementary, supplementary. All things you're supposed to know heading into this. Everyone can hear me okay, right? Probably too low, huh? My grating voice after 2 weeks off. Oh, I know some people are okay. All right, so I'm just stalling. Okay, now we're ready to move on. Concept number 3. New, probably, may have an idea about this. This will come up a couple times. This is not the backbone of like the future, but you'll have to know how to do this in a couple of questions. Minutes in an hour. I don't want this in the chat. Obviously, we know there's 60 minutes in an hour. Now, obviously, we know there's 60 seconds in a minute. Degrees are broken down exactly the same way. So concept number 3 starts off with this little chart. Just like in time, degree measures are broken down into equal units, and they're broken down into 60 equal units. Therefore, they call it 60 minutes. 60 minutes equals 1 degree. Same thing with minutes. Minutes are broken down into seconds. So what's crazy about this is I could barely draw this, but here's an angle measure, and let's pretend that is 1 degree. It's like a real small sliver. I can break that down into 3,600 seconds. Understand how minute that is. I can break this angle down into 3,600 equal parts. That would be 3,600 seconds. Just have that conceptualized in our little geometry sense. Now, why would someone want to do this? Earth is coordinatized. Earth is broken down into a coordinate plane in lines of latitude and longitude, right, everyone? Yes, Mr. Samuelis. So this is why we want to know this for, when we coordinatize very large things like our planet. So I found this interesting. And actually, I found out a lot of stuff. This was 1 or 2 years ago that you don't have to write this down. But, this is something you can discuss at the dinner table with your parents or guardians and the rest of your family. Hey, I just found out something interesting. How many people have heard of a nautical mile? Raise your hand. Nautical mile, right? And that's a mile out in the sea. And I always wondered, why the heck would they make a nautical mile different than a regular mile? How stupid is that? Why do they have to make this world so complicated? Well, I just found out why. By comparison, a statute mile, 5280, is a little bit smaller than a real mile, or a nautical mile, I mean, 87%. So a nautical mile is a little bit bigger. Here's what blew my mind. 1 minute of latitude equals 1 nautical mile. Ooh, that blew my mind. That is why they created a nautical mile. They broke Earth down into 360 degrees in lines of latitude. Sorry, I'm doing that wrong. Latitude goes this way. And then therefore, when they broke that down again, at each degree into 60 minutes, they found that 1 minute came very close to a regular mile. So therefore, they called it a nautical mile. So they had some sort of conversion between that. I found that fascinating. Unfortunately, lines of longitude, probably at the equator, 1 minute equals 1 nautical mile, but then as you move from the equator, they get closer and closer together. So unfortunately, that keeps changing as you slide up the Earth or down, whichever way you want to look at it. So that blew my mind. I'm like, I knew why we would do this. Then I looked up, that stuff and found that quite interesting. So, I always lament about the fractional problems of students and why we don't understand fractions as well as we should. So, of course, what this means is 1 minute is 1/60th of a degree, just like 1 minute is 1/60th of an hour. So fractionally, we need to understand that so that we can convert things back and forth from degrees, minutes, and seconds to actually a decimal, really what this pertains to. Nice. I'd like to see how many people put in the chat. So remember, when we go in the chat, I'm going to do 3, 2, 1 answer, and then I get to see more names. Sometimes when I just throw it out there, one person answers, everyone else is demotivated. But it's kind of fun. I like to see all the names up there as much as possible. It just means you're listening. But, also fun for you to do. All right, and then, of course, I'll zoom this out, just off in the blue there. That I got that off of, I think, actually, when you do a Google search, and the first thing that Google answers, I think that was just the Google answer, the very top thing about a nautical mile. And then, of course, a second, get it all the way down to this, is 1/3600th of a degree. The short, of course, a second is 1/60th of a minute, but it's 1/3600th of a degree. And that will show you how you can deal with this in, changing degrees, minutes, and seconds to a decimal, so it's usable. There are buttons on your calculator that I'm going to show you. I'm not going to show you. Actually, I can't open my calculator. My license expired. So in 2 weeks, I came back after 2 weeks, and 3 things don't work the same as they do just in 2 weeks. Just love change right in the middle of the school year. So any calculator can actually handle the next part, and I'm just going to shove, the notes at you, what you need to do on this, I think. Maybe, but I'm stalling there for those to write that down. I already have that over here, so what I have in blue there. So it's all related to all this. The idea that 60 minutes is 1 degree, so 1 minute is 1/60th of a degree. So on and so forth. Okay, got to move down. Again, I make this video. If something's missed, I'm not putting notes on that are finished online. But what you can do is go to a video and just pull the YouTube until you get to the point in the notes, and then you can stop it. You don't have to listen to me again. You can get to the parts where you miss stuff. So this is the point of this. You're going to actually have to do this. This is not just like a wax on, wax off. Are you listening to me? And are you able to change degrees, minutes, and seconds to a decimal? What you have to understand is later, I'm going to ask you with a calculator, what's the cosine of this angle measure? Well, if you don't know how to type this in your calculator, which I'm not going to show you, then what you have to do is take the cosine of 74 plus 8/60, because 8 minutes is 8/60ths of a degree, plus 14/3600ths, because there are 3,600 seconds in a degree. And then you could press enter then. Okay, but right now for wax on, wax off, can you do this? Can you convert degrees, minutes, seconds to a decimal? This is what you'd have to do. And this is going to come up later. Many questions where you have to do trig in order to solve, they put the angles in degrees, minutes, and seconds. You've got to be able to function that way. Great. I will say this. I didn't say this last hour. If this was a negative angle measure and you had to trig that, just type this, on your calculator, press enter, and then snap a negative on it before you do the cosine of it. We're not doing that yet. I don't want to confuse you. I'm just trying to think of the future. Why are we going to need to know how to do this kind of thing? It is going to come up again. All right. So I just wanted you to be aware of that, because otherwise, putting negative 74 plus 8/60ths, you'll end up getting 73 degrees. You're actually taking away from that. And that's understanding negatives and positives and all that other stuff. Okay, now this one, so this is important. I'm just being honest. This next one I'm probably going to ask you, but not as important. When we have decimal degrees, when we're using it later, that's how we really want it, when we're doing trig on it. But can you reverse the process? So in the chat, what's a half hour? How many minutes is that? 3, 2, 1. Chat. Was that too quick? Boom. It's very easy, isn't it? Oh, nice. Nasir, good. Amber, awesome. Sorry about the other names I missed as you were going up. Many people. It's easy. What's a half hour? It's 0.5 of an hour. But you're probably just doing it because you know the answer. A half of an hour is 30 minutes. But it's half of 60. So you take 0.5 times 60 to get 30. So what is 0.817 of a degree? It is 0.817 times 60. That is the fractional part of what that is as far as degrees and minutes are concerned. Just like 0.5 of 60 is 30 minutes. This is very simple, basic dealing with decimals and understanding it. Okay, how many seconds are there? Well, you have to remember, understand that this fractional part right here, and I am saying fractional part, it is a decimal. Decimals and fractions coincide with each other. That is how many seconds there are. So I take that 0.02 and multiply it by 60 again. Certainly know those note takers that are like, you don't have to write these things down. Then this is just like a reiteration of that. But those are taking every single thing down. Don't really have to do that. It's really about understanding the concept, I think, for the most part. They really break it down. Now, this is out of the book. This is what I mean by the book is like so awesome to look at. The examples are very thorough, very explanatory. Great book. Love it. So anyway, to get that 0.02 minutes into seconds, you multiply by another 60. Because there's 60 seconds in each minute. I know you might think, why didn't I do 3,600? Well, you want to get it into minutes first, and then you got to get minutes to seconds. That's by multiplying by it, because there's 60 seconds in a minute. Okay, so this one not so much as useful, but it's just like, can you do it and understand fractions and decimals? Just being honest. All right. Ready to move on. And sorry for the YouTube video. When we video a class, I do have to wait. I can't pause. A lot of times when I use a different program, I was able to pause and get these little, make a 45-minute video down to like 25. Okay. Okay, I think that's good enough. We can move on. And now I left this blank on purpose. So look at what it says. Just find the complement and supplement. And I cut off the rest of it because that's all that really needs to be done. Let me erase some of this other stuff so it's not confusing. Okay, complement adds up to 90. Watch what I do here. So I need the complement of this. Don't write this down. I'm not going to write 70 degrees. Because you know what I have right now? I already have 90 degrees plus 10 minutes plus 30 seconds. If I do that, and that is not the complement. That's already over 90. So what do I write down instead? What the complement of this? Not 70. In the chat, 3, 2, 1. What am I going to write instead? Because I'm kind of like to borrow a degree. Just gave you a hint. I want to see if anyone knows what I'm going to write instead of 70. 3, 2, 1. No? Nothing in the chat. Oh, 80 plus 20 is 100. So that's a little too big. Thank you for playing, though. I don't want to discourage you from answering. But no one's saying it. Maybe you'll get the next part right. 69. Because you know what 69 plus 29 is? It's 89 degrees plus. So I'm a little lower than 90 because I have minutes and seconds that I have to tack onto this that equal an extra degree. All right. So I'm not going to put 80 minutes here. What am I actually going to, 80, that's terrible. I'm not going to put 50 minutes there. I'm going to put what here in order to save a minute so I can get my seconds here. What do you think I'm going to put here to add to this? Let's see if anyone knows. 3, 2, 1, go. Maybe you don't understand my question. Why would I put 49 minutes? Because 49 plus 10 is 59 minutes. Then maybe we'll get this supplement better. I'm going to put 30 seconds here because 30 plus 30 is 60 seconds. So this is the answer to the complement because 60 seconds is 1 minute. 1 minute tacked on to 59 is 60 minutes. 60 minutes is equal to 1 degree added to 89, which is now 90 degrees. This is called borrowing to understand how degrees, minutes, and seconds are broken down and how we could do this without a calculator. But I will tell you, on the test, this will be a multiple choice question. And me going through this like this, you could probably look at the answers and figure out which one's the right answer by how I'm covering this. Maybe. Otherwise, you know what you'd have to do? You'd have to do this on your calculator. You'd have to type 90 minus 20 plus 10 over 60 plus 30 over 60, get a decimal, get that decimal answer, and then convert the decimal back to degrees, minutes, and seconds. So it's a combination of these two, which takes a lot longer. Understanding the concept is a lot better. So let's try this in the chat. For the supplement, what am I going to put here first? Don't put it in the chat yet. Let me do the 3, 2, 1 thing. For the supplement, using the idea of what I did with complement, what am I going to put here for degrees? 3, 2, 1. I hope somebody answers. Come on, baby. I'll give you a hint. I'm not putting 160. Brian, Alexander, nice. Colin, at least following the idea, but then hopefully you understand why. 159 plus 20 is 179. I'm 1 degree short of 180 because the minutes and seconds are going to make up that extra degree that I need. Did you hear that whistle? All right, and then what am I going to put here? Sorry, for minutes. Don't do it yet. 3, 2, 1, go. Oh, some people put, does that say 159? Oh, yeah, right, because then it adds up. Oh, go. So what am I going to put for minutes? 3, 2, 1, go. I'm not going to put 50 because I have some seconds left over. So I'm going to put what there? It's actually right above it. Right above this blank is what I'm going to put. There we go. 49, nice. Because then what that does is gives me 59 seconds, which leaves me, all right, I'm not going to ask the last one because it's 30. Because 30 plus 30 is 60. So this is a minute. This bumps 59 up to 60 minutes. 60 minutes is that added degree to make that 180. So that is the true supplement of that in degrees, minutes, and seconds. Right? So understanding that borrowing component, probably spending a lot of time in this when we're really not going to do a lot with this, but I do like doing this idea. Do want to erase that though, because these are the answers. Don't want to confuse you. Answer. Again, you could turn this into a decimal, then do 90 minus and 180 minus, but then you got to take the decimal answer and turn it back into degrees, minutes, and seconds. So that takes a lot longer. And it's all calculator work. All right, and probably over-exampling this, but I do have like a Mickey Mouse couple of questions that, like borrowing is used to subtract and all this stuff, and it really solidifies the concept of borrowing a degree kind of idea, how I got these answers for complement and supplement. This one's kind of out of left field. Let's go right to that and then come back. That really was meant to be in with concept number 1. So, okay, what about 90 minus 5128? Well, you could do this, but then this would be in the multiple choice section, and the answers in degrees, minutes, and seconds. This will give you a decimal, and then you'd have to do that example of changing a decimal into, and that's fine. You can do it. Go for it. But what I'm going to do is do what Lexi Samuelis would do with this. Actually, I shouldn't say that anymore. She's in 5th grade now. She subtracted like in 2nd grade, and she had to borrow things. Well, this is kind of a borrowing thing. I can't just do 90 minus 5128, because what am I going to subtract from 28? So I'm going to change 90 to 89 degrees, 60 minutes. This is equal to 90 degrees. But now I have something to subtract from, right? And honestly, this is faster than doing your calculator. It really is. What you have to understand is you are going to subtract and subtract, though. 58 degrees or 51 degrees from 89. Oh, wrong. And then the 28 minutes subtracted from 60. And then it's easy, right? And if you need a calculator, fine, but you're doing less as far as what you have to type. 89, is that 38, I think? And then this is 60, 50, 40, wait a minute, 32, okay, yeah. Sorry for my bad math. My brain is atrophied over the 2 weeks mathematically. Done, okay? Answer done, as long as you understand the borrowing component. All right, I'll leave that there for those writing us. Again, this isn't massively important. But the ability to really turn these into decimals are the best. But I just like playing around with these. And then this one, I'll erase this so you're not confused. We are doing this plus this minus that. But all I was saying is just take those two and add them first. Don't even go to your calculator. Don't even do the decimals. Just add 55 plus 12, which is 67. And go ahead and add 30 plus 44, which is 74. Now, I know 74 minutes is greater than 60, but just hold off. Because then what you can do right underneath that is then do the subtraction. Subtract 8 and also subtract 15. And then you end up getting, weirdly, 59 degrees. And now that I subtract, I do end up getting less than 60 minutes. And that's the answer. Look how fast I did that without going to my calculator because I'm afraid. I just want to get answers with the calculator spit out at me. It takes like 5 times longer to go to the calculator. Really the idea there. All right. All right, then the last thing before we go on to concept number 4, I believe, this has been overdone as far as how important this is throughout the year. On the chat, tell me the relationship between these two angle measures. Then I'm going to show you this next one. Wait till I say 3, 2, 1. 3, 2, 1, go. This actually kind of belongs in the Ed puzzle. Get a lot of nice. Someone tell me what that actually means then. You are 100% correct. I just want to make sure you know what that means. Equals 180. Cool. So you got these simple little geometry questions throughout. This is to make sure, because these concepts are huge later. If we don't know them, we're done. It's like going to be an awful year if we don't know supplementary, complementary. We don't know that these two add up to 180 and don't know how to solve for it. Ooh, it'll be rough. All right? And then to get what these angle measures are, you plug in X. So it's 70 and 110 when you plug that in, and those certainly add up to 1. So that belongs with concept number 1 or concept number 2. We were talking about like types of angle measures and what they add up to be, that kind of thing. You see 2 angle measures that look like this, and it cuts this, and this one's X, and this one's 2X. Those add up to 90. So X plus 2X equals 90, and then you go from there. Just those ideas of understanding. But I shouldn't have to leave that there. Wait, put that back. What did you just say there? You got to know that. That's pretty basic stuff there, right? And then complementary, of course, we know that complementary means they add up to 90. So if that's the case and you're solving for X, these are those algebra questions that you just love being asked. But we're just exercising, do you know the term? Remember, C, 90, S, 180. Goes in order. Good. Some other people I see in the chat there. Awesome. It really says a lot when I see your names up there too. Make mental ideas and so on and so forth. So it's really cool that you guys are doing that. Much appreciated. All right, let's get to the big concept. 9:51. Really would like to be done by 10 because this next big concept, all there is a whole bunch of different questions asking the same thing. It really is. So just let's make sure we understand that. And I'm going to start by calling this concept number 4 and just call it angles said to be in standard position, which this is what's going to go through all the way till May. Oh, man. If you get this now, and actually it's not a very hard concept. Many of you will get it. I just get sad, not thinking about you guys, but CAT students of the past. For weeks, they don't get this concept down. And for weeks, not getting this concept down causes their major destruction in this CAT class. I cannot be more adamant how important this is to get this down. And the majority of you will be like, it's not really that bad. And you're right, it isn't. You just focus and follow along. And what angles are, I'm not putting this in words, but here's what I said all the way back in concept number 1. We are going to stick angles in a coordinate plane, right? And that's huge. It's like putting Earth in a coordinate plane, all right? It gives us locations. It gives us locators. It's not just about maps and anything like this. Engineers do this. They use trig, but then it's location of objects and whatever they're engineering. So coordinate planing stuff is a huge deal. So that's why the rest of the year, it's trig in a coordinate plane. Because I remember students in the past, like after a couple weeks doing this, why are we putting this stuff in coordinate planes? What are we doing? And I know you're not going to be an engineer maybe, but there's other aspects to why this is a thing. So just keep that in mind. Anyone that expects to go to calculus in college, well, this is a big deal. Okay, trig is anyway. So what is it to be in standard position? The positive x-axis will always be the starting point of an angle rotationally. So that's just it. You lock it in. When I say an angle is in standard position and its measure is, you start at the positive x-axis, and then there's some terminal side somewhere. So, fine. And let's just say a reasonable answer or a reasonable angle measure for this is like 50 degrees, right? You know that because I'm just guessing, giving an estimate of what that angle is. We should know that it's between 0 and 90, knowing that it's an acute angle. There's that little term up there up at the concept number 2. We should know that if this is the starting position of this angle measure, and this one lands around here, a reasonable angle measure for this would be like 150. We should know we're greater than 90, but less than 180. This should be common sense as far as knowing an obtuse angle. Then your world's going to get nuts. I already showed you that you're going to have angles greater than 180. And you're also going to have angles that are 360, but even bigger. And that's what you're going to have to know when I give you an angle measure like 1,000 degrees. You're going to have to know what quadrant that lands. You might have to have a calculator to kind of do some stuff. It's pretty simple what you have to do. So I don't know if you want to incorporate this in one of these. Don't do all 3 drawings. All this is saying is you better know your quadrants. 1, 2, 3, and 4. Right? That's the order. Just like positive angle measures, counterclockwise. I don't know if my hand's doing that the way you see me, but so yeah, just like I said, between 0 and 90, your angle measure would be in quadrant 1. If your angle measure was between 180 and 90, then you're somewhere in this quadrant. That's where the terminal side is. Okay, now for the first time maybe in forever, you have angles greater than 180. So that's like that one thing that I had. Actually, I did not have a quadrant 3. So say you had 200 degrees. That lands in quadrant 3. And that's the things that we need to know. Where does 200 degrees land? Quadrant 3. Then we're going to incorporate a new angle measure called radians. That's fractions. All right, and that's really the biggest problem with radians. When we get those, understanding fractions is the only problem. Sadly it is. And then the one that we had up there, I think we called that 300 degrees. We ended up in quadrant 4. So that's what all those little inequalities say right there. You know, you should be aware of that, and then your world's going to get bigger. Like I said, you're going to have to know where 1,000 degrees are. You're going to have to know where negative 1,000 degrees are by going clockwise and doing some stuff. Pause and take an attendance at some point on these. Hate to do that during the video of this, but yep, this is the big deal. So standard position, we start at the x-axis and then we move. Get ready for the chat. Okay, so here's another example. Okay, coterminal angles is really within concept number 4. By the way, co means same, co-workers, workers of the same department. Terminal is ending, same ending side. That's what coterminal angles share. They have the same ending side in a coordinate plane. Just simple English breaking down that word, into its parts. So here's, of course, they have the same initial side, the positive x-axis. Same initial side, which is in standard form positive x-axis, same terminal side. All right, now here we go. I'm going to ask you something in the chat. Be ready. So here we go. Positive x-axis, always the initial side. Then this one we just ended up in quadrant 1. And then we threw an angle measure 60 degrees. Is said we got a protractor, we measured it, and that's 60 degrees. Great. Why is 420 degrees in the same position? Because it quite simply is Kmart's parking lot. I do a donut. So I did 360. Then I did another 60. And these two cars end up facing in the same direction. Hence, they are coterminal. And that's the main idea of how angles end up being coterminal. The key is 360. 360 is one rotation, and that is the key to find angles that are coterminal with each other. Really is. That's the relationship. That's all you really need to know. Oh, no. Hopefully it makes it. Gosh, I have like a week left in quarantine. So actually, they said Brianna could be released January 11th. Then seems a little shorter than a 2-week thing. I don't know. Maybe I can go back to the school. There is kind of have to. I'm missing some things at home here. All right, in the chat, what is this? Don't do it yet. Okay, that's okay. No, that's the case. Don't do it yet. What is this green angle measure? Wait for the 3, 2, 1. What is that green angle measure that lands in that same terminal position? 3, 2, 1. Answer. Ooh, we have two different answers from two different people. Are either one of them right anyway? Come on, let's get some more people other than two. Maybe the two that answers, one of you have to change your answer. I'm interested to see. Uh-oh. It seems to be falling apart. Who's there you go, Michael. All right. Yeah, it's -300. I think it was Skylar that got it first. Hard to scroll up in there. I don't want to give you credit if you don't. Yes, it was Skylar. Okay, nicely done, Skylar. -300. Again, the relationship between -300 and 60 is, if you lop off the -360 is 360. That's the relationship between coterminal angles and how we find those. Good. Seeing all those people put that down is great. And then I'll show this one. You don't have to take the second one down. Again, this is like over-exampling, I bet. But let's say we have this first angle measure, positive x-axis. And then we end up in quadrant 2, which has got to be greater than 90. So let's just say it's 110 degrees. Don't put anything in the chat yet. How do I get 830? Quite simply, it's 360 plus another 360. Imagine this crazy person in the Kmart parking lot. And then another 110. All right, 360. 360 again. Then 110. That is the idea of coterminal angle measures. Okay, when I ask, what's the green angle measure? I'm doing a countdown. 3, 2, 1. Answer. Let's see who wins now that the answering is open. I got nobody. Got nobody. What's the green angle measure? Oh, Marissa left. I'm not answering any of your questions. I'm out of here. Nice. -250 from quite a few people, many that have answered before. Much appreciated. It is -250. Again, the relationship between -250 and 110, lop off the negative, they add up to 360. That's how coterminal angles work. You got this now. Feel good that the backbone of the rest of the year you have solidified. Yikes! I didn't erase these. Nobody look. Right? And all of these questions that I have coming up here are really all the same question, just worded differently. And I think we could do this in the chat. Find the angle of least positive measure, not equal to the given measure, coterminal with this. I told you 1,000 degrees was coming up. 3, 2, 1 in the chat. This may take longer. What do you think the answer is? Now you might not. You probably use a calculator on this. What is the least positive measure equal to 1,000 degrees? Now I'm going to go ahead and put a graph on this. 1,000 degrees goes counterclockwise. That measure. Well, that's not enough. So that measure, that's still not enough. That tells me mathematically what I have to do to find out just what this part is. I only want to find the leftover part. So what is the answer to that? Please. So what I just intimated in red is I want to subtract the 360. I I want to subtract another 360. I know that's 720. That leaves 280 left over. So the blue angle measure is what's left over after those two rotations. This is what I mean about knowing 1,000 degrees ends up in quadrant 4. You need to subtract out those rotations that get you right back to where you started. How you doing, Nathan? You doing better? All right. That's it. I mean, this is what it's all about. Let's go to the next one. Ooh. Give 2 positive and 2 negative coterminal angles. That's all you really have to write. Don't write all the words. Be good note takers. To this angle measure. In the chat, put any of the answers. If you want to put all, go for it. I don't see anyone that gets this right now. I'm going to say this, though. You don't have to graph it, but here's where 90 degrees lands. So then, how do I name this? Or how do I name, this is going to get ugly. This. That action tells you what you have to do mathematically. You get this. It ain't no thing. No one's going to put it in chat? All right. The first action that I did is I added 360 to this. So one of the positive angle measures is 450. But then I need another positive coterminal angle. So instead of just doing 1 extra rotation, let's do 2 extra rotations and then a 90. Oh, there we go. Caesar, look at Caesar. Nice, Caesar, that is awesome. So I don't even have to go to my calculator. Caesar put positive 810. And now I need 2 negative, which means I go back to the original and I subtract 360. Look at Caesar's answer. Negative 270 is correct. Hey, let's graph that real quick. Here's negative 270 going clockwise, negative 90, negative 180. Yeah, negative 270. I land right in that position again. And then subtract 360 again. Right, and then we're getting close to wanting to be done here. I think he's right. It is negative 630. Did this last hour as well. So again, it's the same question, just adding some stuff, you know, and then understanding that we could do this forever. I could name this angle measure here and here an infinite amount of ways by continually adding and subtracting 360. And that's the idea that you have to understand here, which leads to this question. Give an expression that generates all coterminal angles, right? So I'm just going to throw the answer at you, but I'm going to explain, let n represent any integer. And I'll leave that last one up there if you were still taking those down. Take a minute here. You don't have to write this part down, but n is going to be used in this expression. N being an integer, it makes me sad that we don't do this too much anymore. We used to start Cat with reminding you the subset of numbers. I think I might have done it when we did imaginary numbers, showed the subset of numbers, but that's what integers are. All of those forever. Negative 3, negative 2, negative 1, 0, 1, 2, 3. No fractions and decimals, positives and negatives. So what are all of the coterminal angles to negative 90? Well, what do we do to find coterminals? We added or subtracted 360. So when you tack on this little component there, this generates every single coterminal angle. All right, and that's the answer. I want to explain it further, though, because that's what I do. Whether people want to rip on my teaching method or not. Oh, got some rough emails at the end of last semester. Boy, oh boy. People are getting more and more vicious these days. 0 plugged in gives me negative 90. Right, because 360 times 0 is nothing. But when I plug in 1 for n, that's the first rotation of 360 degrees. 360 plus negative 90 is 270. If I plug in 2, then I get 2 extra rotations plus that negative 90. When I plug in negative 1, then I start going in the opposite direction with an extra rotation. I'm just trying to explain why this expression actually generates all of the coterminal angle measures, as long as I understand what an integer is, right? And then that's pretty good, right? All right. So a little different there. We have to do this later, like being able to answer what are all of the answers instead of just a couple. So this idea comes up a little bit here and there. Then I'll end with this one. We're not doing that. It's the same question written in a different way. Yeah, don't look. Oh, I gotta go make this real small. Good. You can't see. Zoom that in real fast. I thought I erased all my notes. Okay. I'll make sure I do this for the next hour. Okay. A lot of wording in here. Don't write it down. This is all we have to do. Well, I just don't want you to be like note-taking robots. All right. Just what is the angle measure? Okay, so we're gonna draw this. We're gonna go to -3, -3, and then this is a huge part of this book as well. Just knowing how to work in a coordinate plane. -3, -3, and this is what the directions say, just in the shorthand. And then draw a ray through that. From this coordinate, what is that angle measure in standard position? So what is this angle measure from here to here? Don't answer that. Let's break this down. I want to know, what is that angle measure right there? I bet you someone in the chat can figure this out. It's open. Tell me what the answer is whenever you're ready. By the way, I did mark those two sides as equal because they are equal. That makes this triangle a right triangle because of how I move with coordinates. I go left and down. And then, since it's a right triangle and those are two equal sides, what does that angle measure have to be? Good, Alexander and Aiden. Awesomely done. You are darn right, that has to be 45 degrees. So does that, but really, this is the key to find out what this total angle measure is. The chat is open. What is the total angle measure if I have to go from here to here, then I have to go this much farther? Nice, look at Michael. That's the answer to this question. When we get to the end, if I do have coordinate questions, they're going to ask that. Now, it might be a little bit more challenging. Really, we can only do like 1, 1, -2, 2 right now, unless you remember your 30, 60, 90s and recognize side measures that work with those. But that's where your world's going to expand to. We're definitely going to teach that. So again, they were just kind of playing a game with coordinates because this is going to be coordinate trig. You're going to be dealing with coordinates a lot in the coordinate plane, then converting this to angle measures, and then doing trig with it. Huge, huge component of chapter 2 right off the bat, and actually chapter 3. Knowing your coordinate planes and knowing these angle measures. All right, I'm blabbering now. We're done. If you want to stick around and ask me a question, go for it. Any problems or issues? Again, I'm here from 2 to 3. Students are not, don't go yet. Students are not doing their stuff. I have to be more proactive by administration about assigning people to be with me from 1 to 2. Do look to that. I would prefer it that you do it in your own recognizance and start showing up from 2 to 3. Unfortunately, I'm getting a lot of people not doing that, but also not doing their work, and then that's where I have to step in. I'm being forced to. Just keep that in mind as we move forward. Hopefully, being adults, you make the choices to make those changes. Otherwise, forced to do that. It's not a bad thing. I just prefer students' own decisions, get things done on their own, and be proactive. So, all right. That's it. You can go. If you have any questions, feel free to stick around.